So I'm joined by some lovely gents from the National University of Singapore. Howja,
Hi.
talk to us a little bit about the technology we've got on display.
Yes, sure. So what we have on display here is an object-independent robotic grasping system. So this robotic grasping system decides how to grasp objects, not based on object category, but based on the geometric features of the object. So what we see on screen here right now is the RGB image of each of the objects, the depth of the objects, the depth image, which tells us how deep the robot arm must go down so that we can grasp the objects. And then it selects from the objects on the table the optimal grasping point for an object. And then as the rectangle rotates, it is actually telling us how the angle of the gripper and also the width of the gripper needs to be positioned so that we can grasp the object. Yeah.
So what inspired you to undertake such a project?
So we looked at some of the grasping algorithms, previous works done by other researchers, and we realized that a lot of the algorithms either look at open loop scenarios. So we take one picture, and then we decide how to grasp the object based on that one picture alone, or other types of grasping algorithms which train the algorithm to grasp only objects of certain categories. But there are limitations to both these approaches. So we decided, and we thought from a more human perspective. So if a human wants to grasp an object, it does not need to know what category it is. It is able to grasp an unknown object, even though it doesn't know what it is. And then even as an object is moving around on the table, I am still able to follow the object to grasp it. So it's able to react to these dynamic conditions. So we thought, can we train a machine to do the same? So what we've done here is we've given the machine tens of thousands of images of different objects, shapes, sizes, geometric features. We wanted to give the machine as much variety of geometric features as possible so that it can learn to generalize to different objects, even those that it has never seen before. So everything from this basket that we have here is not seen by the machine, has not been seen by the machine during training. Yeah.
So what I want to know is what kind of use cases are you guys considering for this?
Okay, so one of the immediately applicable use cases would be warehouse packing. So let's say you're in a warehouse, you have conveyor belts of objects coming on. You want to pack these objects. So that would be one of the use cases. This algorithm is actually able to run pretty fast. We're limited currently by the speed of the actuators, but we're looking at a speed of potentially 50 to 100 frames per second. So we're able to do this really fast and really accurately. Yeah.
So being robotic students here in Singapore, how important is it for you guys to showcase your technology at ATxSG?
So this exhibition actually provides us with a platform to interact with end users and also potential collaborators who are interested in the technology and are willing to collaborate with us to bring this technology further. We also want to understand more about the different needs of end users, how we can continue to further our research to tailor more to their needs. Yeah.
So what can we expect from your project for the next 12 months? How are you working on?
So we do have future plans to bring the intelligence of the algorithm to the next level. So one of the aspects we're looking at would be object functional awareness. So certain objects have certain functions. So for example, you have screwdrivers, you have scissors. So these objects are used to perform tasks. So, and how you would grasp these objects is more specific. So we can't grab it in a way that as long as we pick it up, it's fine. So you need to be able to grasp the object so that we can perform those tasks. And how do we train the algorithm to recognize these types of objects are able to perform these tasks? They have these functions. And how should I grab the objects such that I can realize these functions? Yeah.
Well, I look forward to seeing you guys develop it even further in the next year.
Thank you. Thank you. Thanks
Thank you so much.
Thank you.